Power and energy in circuits. Power delivered by the EMF source is equals to the rate at which the work is being done. So the power is equals to delta W over delta T, which is equals to EMF delta Q over delta T, or EMF I. For a circuit with a source of EMF and a resistance, delta U equals delta Q delta V, or P equals I squared R. Or P can also be written as delta V over R. The energy transferred to a resistor in a circuit is often known as Joule heating. In a real battery with internal resistance R, the potential difference between the terminal is EMF minus IR, where R is the internal resistance. The charge passing through the battery gains potential energy. So delta U equals delta Q plus delta V battery equals dQ EMF minus IR. Then the power delivered by this battery will be P equals VI minus I squared R, or the power from the electromotive force minus the power that is dissipated through the internal resistance. A flashlight is powered by a battery in series. Each has an EMF of 1.5 volts and an internal resistance of 0.1 ohm. The batteries are connected to the light bulb by wires of total resistance 0.4. At normal operating temperature, the resistance of the filament is 9.7 ohms. Calculate the power dissipated by the bulb, that is, the rate at which the energy in the form of heat and light flows away from it. Calculate the power dissipated by the wires and the net power supplied by the batteries. A second flash bulb uses 4 batteries in series and the same resistance wire. A bulb of resistance 42.1 ohm at operating temperature dissipates approximately the same power as the bulb in the first flashlight. Verify that the power dissipated by the wire is nearly the same and calculate the power dissipated by the wires and the net power supplied by the batteries. So, in this question, we have 2 flashlights. Okay, and it says that it has 2 batteries in series. Okay, and the EMF is 1.5 volts, and the internal R is 0.1 ohms. Okay, the resistance of the wires is 0.4 ohms, and the resistance of filament is 9.7 ohms. Now, how do I draw this picture? So I have 2 batteries in series with each other. So I can redraw them like this. So it'll have like a EMF source and an internal resistance, an EMF source and an internal resistance, right? So these are my 2 batteries. This will provide E1, E2, R1, R2, and then I have a wire. Wires have resistance of 0.4, so I can replace that and call that my wire resistance, and that is 0.4 ohms. And it has a filament for the flashlight, and that filament has 9.7 ohm resistance, okay? Now it's asking me the power dissipated by the bulb is what I am looking for, or the rate at which the energy is converted to heat. Now the formula, the power that is dissipated by the bulb or the filament, so is going to be I squared R. Now, what is I squared R? I actually don't know what I is or R is, but I do know that this has to be I total and R equivalent of this entire circuit. How do I find R equivalent? Well, let's start with R equivalent. These are all in series with each other, so that means I will have to find R equivalent as if they were all in series. Well, they are all in series. So I will have resistance of the wire plus resistance of the filament plus internal resistance of the battery, 1, and internal resistance of the battery, 2. So in fact, in total, if I add all of them up, it'll be 9.7 plus, resistance of the wire was 0.4 plus 9.7 plus internal resistance was 0.1 plus 0.1, and I get 10.3 ohms for my R equivalent. Now what about I total? I know Ohm's law says V equals IR. What is V? V is actually equals to the two batteries in series. So if these two are in series, then my V is equals to E1 plus E2. So if it is 1.5 volts, it'll be 3 volts in total, right? R is going to be my R equivalent, which I can get from here. So this means I can find the value of I total, which comes out to be 0.29 amps. Okay? Now that I have my R equivalent as well as my I total, I can plug them back in here to find the P of the filament, which is 0.29 amps squared times 10.3, and I believe that answer comes out to be 0.823 watts, right, which is the unit of power. Next, in part B, it asks us to find the power dissipated by wires. Well, that one's easy, so it'll just be I squared times the resistance of the wire, which I can easily say it's 0.29 times squared times 0.4, because that's the resistance of the wire, comes out to be 0.034 watts. Okay? And it also asks me for what is the net power supplied by the batteries. How do I find that? That one is interesting because the net power supplied by the battery is E of the battery times I total minus I squared R, which is R equivalent of these two little guys, right? Because the total power that's supplied by the battery includes total EMF of both batteries minus the R equivalent, that's the internal resistance, the amount that's taken away internally from the batteries, right? So what is I? I is nothing other than I total. And what is E? E is the total battery voltage, which is 3 volts. This one plus that one. I total is 0.29 amps minus 0.29 amps squared, and R equivalent, right, in this case will be little I plus little r2. So each of them is 0.1, so this would be equals to 0.2. Plug in the numbers, calculate, it comes out to be 0.857 watts. Now, for part C, it says that we have a second flashlight. So we have a second flashlight that uses 4 batteries in series and same resistance wire, same R wires, and the bulb is 42.1 ohms. So in this case, what would it look like? This picture would look like this. So this would be my bulb, and instead of having only 2 batteries, it will now have 4 batteries, right? So just for comparison's sake, I've left the other one on. So this is going to also have a battery, an internal resistance, a battery, an internal resistance, a battery, an internal resistance, a battery, and internal resistance, right? So this will be 1, 2, 3, 4, and the resistance of the wire will be same, but this one will be 42.1 ohms. So we need to calculate what the power dissipated will be. We know power is equals to I squared R, right, in all of these cases. So we need to find what R equivalent is. So R equivalent in this case will be R of the filament plus R of wire plus 4 times internal R's, right? And I will be nothing other than V total divided by R equivalent. So what is V total? V total is the sum, and since there are 4 batteries in series, it will be the sum of all 4 EMFs. So that would be 6 divided by R equivalent. And if you find the value of R equivalent, what we find is that I total comes out to be 0.14 amps. Okay? Once we have all of those values, we can find the power for the filament as I squared R of the filament. We can find the power dissipated by the wire as I squared R of the wire. And we can find the power of the battery by total EMF times I total minus I squared R equivalent of the little tiny internal resistances, right? If I plug all the values in, I get 0.813 watts. For this one, I get 0.0077 watts. For this one, I get 0.831 watts. But please make sure that you recheck them and confirm that these answers are correct.